Okay, and we're back. This time, as I mentioned in the previous video, I had a couple of attempts to create our very initial version of the game infrastructure using Terraform. This setup will be used to prove that our idea for having a static connection from the client, which is our player, to the server, which is not actually a server, but a set of a serial solution would work. I started with thinking what our subdomains would look like, and I thought splitting them by the type would make sense. Hence, I've got several main subdomains. They are API and WS. We will use the API subdomains for the normal HTTP REST calls APIs. And the WS subdomain will be used for the WebSocket APIs. This structure will leave us some room for other subdomains if we need them in the future. Examples can be if we decide to have a dedicated part of our website as a player account, for example, or have the game to be released on the web under a particular subdomain. On the screen, you can see my first attempt to have this all coded in the HCL language, which stands for HashiCorp Configuration Language. This is the default language used for Terraform. Well, this quickly became overly complex considering the nested domain structure, deep connections between the domain resources like SSL certificates, both global and regional ones, regional API gateways, domain routes to connect endpoints to our Lambda functions, and much more. After fighting with this for several days, I gave up and tried another solution, which is using TypeScript for Terraform instead of HCL language. This worked much better for me, as leveraging proper TypeScript data structures and language features made it much easier to manage all dependencies I mentioned earlier. Now on the screen, you see the final version of what I currently have. This code requires only the main domain, then it creates all hosted zones for this domain and with all subdomains as well. It orders all required SSL certificates, adds validations for the certs to our domain records, creates regional API gateways to serve the regional entry points. Remember the slide from the previous video where a player would be redirected to the closest region? That's it. Then it connects these regional API gateways to the regional set of lambdas. Each lambda will handle a separate subdomain for now, using routes specified in the configuration. For each region, one set of API and Lambda functions will be created. Then the code puts latency DNS records to the hosted zones, so our DNS knows how and where to redirect our players. Together with this, the code creates the DynamoDB tables with replicas in the exactly same regions that we used to create the original entry points, which is API gateways. We will have to come back to this later and optimize it for a large number of players, as our infrastructure might become overly complex and expensive when many players are within each other's area of visibility. And each of them will have to send updates to all other players, which basically uses the math power to generate the updates requests. We will have somehow probably group the messages, but I haven't thought through this one yet. For now, this info will be enough for us to test our game with 2 players. In the next video, we will start writing some C# code in Unity to be able to connect to our WebSocket APIs to establish the player-to-server connection to send and receive updates. A couple of challenges for the next step is the Lambda cold start. I've done some testing after the whole infra is provisioned now, and the numbers are not so great as I initially thought they would be. It takes around 900 milliseconds to get the first reply from the server when the Lambda is shut down. The subsequent messages return within 300 milliseconds, which is fine. This is considering I'm in New Zealand and the closest region to me is Australia, Sydney. Let's see what we can do about this. I don't think we can speed it up for now, but maybe let's think about how we can mitigate it. Thank you, guys, and see you in the next video.